All right, today we learned about single nucleotide polymorphisms. I'm going to give you a short tutorial on how to do this assignment. It's a little confusing, but I think with a little extra explanation in this video, you'll actually understand what to do. So, first of all, you're going to want to open up this one, DNA testing PDF. You're going to open the assignment with Cami. If you can't open it with Cami, then just answer the questions on a separate sheet of paper, then upload your assignment to Schoology. And the neat thing about Cami and all of its functions is that you can basically annotate a PDF. So if a teacher sends you a PDF, you can annotate it pretty easily with text boxes, or you can mark it up with drawings. So first of all, geneticists look for changes in DNA to determine if there's a link between certain diseases and DNA. Although most of your DNA is the same as the person sitting next to you, there are subtle changes that make you different. Where you may have a cytosine in your genome, which is a fancy word for your genes, we learned that yesterday, the person next to you may have an adenine. Remember, there are 4 bases in DNA. This tiny change may put you at risk to develop certain genetic diseases like Alzheimer's. These tiny changes are called single nucleotide polymorphisms, or SNPs. So today, you'll look at a section of DNA for 12 individuals, 12 patients, to determine whether which people are at risk for developing a certain genetic disease. You're going to compare each DNA section to that of a person's DNA who does not have any genetic markers linked to a disease. After that, you'll determine if the location of the SNP, right, the mutation, is linked to a genetic disease, okay? And so just to show you, this is the healthy DNA. So we're going to compare each patient DNA, all 12 patients, there are 12 of them, to this section of the genome, okay? So patient 1, a 27-year-old single mother of 3. Patient number 2, an 18-year-old male. Patient 3, a 67-year-old retired Air Force pilot. Patient 4, a 58-year-old CEO of Medtronic. Patient 5, a 28-year-old manager at McDonald's. Patient 6, a 7-year-old girl. Patient 7 is basically you, okay? Patient 8 is me, a science teacher at the alternative high school. Patient 9 is our math teacher, Charlie. Patient 10 is a 99-year-old father of 5, grandfather of 14, basically someone who almost makes it to 100. Patient 11 is going to be your mom, so you can put in their name there. So if you use a text box, right, my mom's name is Sue, so I can put that in there. And patient 12 is your younger brother or sister, okay? Or maybe a cousin if you don't have any brothers or sisters. And so you can see right here, you can use the table below to organize your information. If the patient is healthy, put an X in both boxes. And when I say they're healthy, their DNA is the same as the healthy DNA, okay, of our 12 patients. If there is an error in their DNA, you're going to put down what the change is. So for example, a C is now an A on the genome. So the C would be the healthy DNA and the A would be the change that we've observed. And then you would tell us which nucleotide of the 12, there's 16 nucleotides that has actually changed. And then there are 4 follow-up questions about this, okay? So I'm going to take you through the next step. Here you can see the healthy DNA. You go back into the module, and here are the DNA results. It's actually on this document too, because you can see them all here, but it's too hard for you guys to go ahead and compare the healthy DNA all the way up here to the top. I mean, if you want to look at it, one's a T, and down here's a T. It's way easier if you do it this way. And this is how we do it in class too. You're going to open up the DNA results just as a PDF, okay? And notice it's sideways. So the way to cure this is to go ahead and download this to your computer, to your Chromebook, and then you'll be able to manipulate this. And you see this button up here? You're going to click this button so it rotates this until we get the orientation just right. There, we can read all of these. So like I said, these are 12 patients. They've submitted a sample of their DNA, and we're going to compare their letters to healthy DNA to see if they've got a misprint, a mutation, a SNP, okay? So now what you're going to want to do is get this document up and maybe adjust, the windows here so you can see the healthy DNA. Then you're going to click on this, and notice the format's a little bit too large. If you adjust the size of this, you can get it pretty close to the same size as what we're seeing over here. Okay, this is pretty close. I'm gonna make it just a little bit bigger. So bear with me, folks, just so I can kind of see it. And it would be nice if it was all the way over. Now, like I said, this is a paper assignment that we do in Biology B. And we're trying to do this now on the digital scale. I don't think it'll be that difficult. It takes a little while, but I think you'll get the gist of it, especially if you've done the previous assignment to this one where we looked at what a doctor's not telling you about your DNA. All right, so the directions are to compare these DNA samples from our 12 patients to the healthy DNA and to look for an error. So that first patient, patient number 1, right? The medical device salesperson. I think they have 3 children. You can see on a healthy DNA there's a T, and she has a T, so that's good. Here at 2, we got an A and an A. At position 3, there's a T and a T. At position 4, there's an A and an A. At position 5, there's a T and a T, so this is good. 6, there's a C and a C. 7, there's a G and a G. 8, there's an A and an A. 9, GG. 10, GG. 11, CA. 11, CA. So there's the error, folks, right there. And so I'm just going to go ahead. I know that if I go up to here, I can get some tools on PDFs. So like I said, at the 11, there's a C. I'm just going to circle this A, okay? So this is the misprint. This is the error that this person has. Ooh, it's right there. Okay, it filled it in. Anyhow, I think what I gotta do is do this. So no filling in. There we go. There's my error. So a C is an A and it's at the 11th nucleotide. So in order for you to get credit for this, and I'm going to give you this one, the SNP here is a C turned into an A. And this happened at the 11th nucleotide. Okay, so this is the misprint. This means that this could be linked to some type of genetic disease. And for the sake of this, it kind of does, okay, which you'll see in a little bit. So going back to this, we're going to do one more together. We're going to see if we can't find an error in the second patient. And this is probably going to make it a little bit easier for you moving forward. So, all right, so let's check it out. Patient 2, who is the 18-year-old male going to the University of Minnesota. So a T and a T, A and an A, T and a T, A and an A, T and a T, C and a C, G and a G, A and an A, G and a G, 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 C, 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 A, C, G, or C, C, and then G, G. So this person here, their DNA is healthy. So what I would do is I would make a little text box right above this individual to help, to help you with this. And type in there that this is a healthy strand of DNA. That 18-year-old male has healthy DNA. And now instead of having to go all the way over here to compare this for the next patients as you move through here, you can just go back and forth here now. So for patient number 3, TT, AA, TT, AA, it's way easier now for you to do this. I couldn't fix the formatting with it. I apologize. And we just kind of have to go with this as we move forward. So patient number 2, go down here. And you're going to get a text box. And it says to put an X if the patient is healthy. And so if you were a doctor and patient 2 came to see you to get their DNA tested, you would send them something in the mail, or you'd send them an email that says, hey, their test results are negative, which is a good thing in medicine to have negative results, okay? I know that's a little confusing for most people, but hey, you want negative results when you see the doctor, all right? Unless it's something they cannot find a cure for. They can't explain what's going wrong with you, which is somewhat frustrating. So you'll have 4 questions to answer, but I really want to get into this genetic diseases for this first patient to show you what we're talking about. So for question 1, which individuals had a single nucleotide polymorphism? Patient 1 did. Patient 1. And you go through here and figure out what the other ones are, because there's more. And then for the second part here. What diseases are these individuals genetically predisposed for? So patient one, what you're going to do is compare this 11th nucleotide SNP to the genetic database. And if you scroll down, you'll see the genetic database that I put in here. So like I said before, match the single nucleotide polymorphism, the SNP, of the patient to the potential disease with this genetic database. So it's the 11th nucleotide, right? That's where the SNP occurred. And this individual has a 28% chance of developing brain cancer. Okay? And so what you're going to do is come up here. That's what I'm going to be checking for later. 28% chance of brain cancer. And just to clarify, this was the individual, it's patient one. I always like to put down what this person is, who they are, and this is the young mom, okay? She's got 3 young children to take care of. Which really brings you to the third question. If you were a medical doctor, and I know you're not, but you're going to pretend to be one today, what kind of advice would you give this young mom? You know, we always say that a probability isn't a certainty. And 28% chance, it's higher than 0%, obviously, but it's not like 50% or 75%. But knowing what you know about cancer, what kind of advice would you give this young mom? Okay. And what I would say as a medical professional is that if I knew I was genetically predisposed to a certain type of cancer, I would go in for screenings on a more regular basis. Does that make sense? When I say screenings, I mean go see a medical professional and have them maybe do a CAT scan to see if there's any type of tumors in my brain. Does that make sense? It's going to cost you probably a little bit more money, but I think with having 3 children like this mom, she's going to want to be able to be there for all the things that those children are going to go through in life, from being teenagers to going off to college to getting married to having grandkids. She might want to be there for them. And the best way to do that is to get ahead of cancer, okay? And so that's where you're going to come in and you're going to give these some advice to each of these patients. And now, when you look at question 4, and this is on a personal level for you, choose one of these diseases down here. And maybe you know somebody who has Alzheimer's, or maybe somebody in your family has diabetes. You know, then you look at that individual and maybe what is the likelihood of you developing something like this? Do you know that you're at risk already for one of these diseases, or maybe a different disease that I don't have listed here? Make this personal for you when you answer question 4, okay? Because usually when we find out there's a disease, there is some type of genetic component linked to it, okay? Unless it's an infectious disease. But even now, when we look at infectious diseases, we see that some people are more likely to have adverse reactions to infectious agents, okay? And it might be related to their DNA. I hope this makes sense. If you have questions, I'm always available for help. You can email me at bkabilka@sowashco.org or through the Gmail, which is on your in your Gmail. I should pop up if you type in my last name, Kobilka, or always through Schoology. All right. I hope that was helpful. And like I said, if you have any questions, do not hesitate to ask. Okay? That's what I'm here for.